Dear students, welcome to our science episodes. Today we are going to discuss the main groups in the periodic table. Alkali metals. Alkali metals are located on the left side of the modern periodic table. They are actually group 1A, the first column in the periodic table. The first group of the S block. Look to this one, this element. This element is hydrogen. Hydrogen is the first element in group 1A, but it's a non-metal. So it's not included in these alkali metals. What are the properties of the alkali metals? They are solid metals at normal temperature with metallic shine or luster. They are good conductors of heat and electricity. Lithium, sodium, and potassium, the first three elements, they float on water surface as their densities are less than the density of water, which is 1 gram per cubic centimeter. While rubidium and cesium sink in water as their densities are more than that of water. What are the chemical properties of alkali metals? Can you see that the reactivity increases while going down? So this means, for example, that sodium is more reactive than lithium and potassium is more reactive than sodium and so on. Alkali metals are monovalent, and because they are in group 1, they have only one electron in their outermost energy level. As we said before, in the properties of the metals, they tend to lose their valency or the electrons in the outermost energy level during chemical reaction. Why? To form positive ions. Why they are positive ions? They are positive ions because these metals are losing electrons, and electrons are carrying negative charges. When I will give away, or when the atom will give away the negative charges, then the positive charges of the protons will be more. That's why they acquire a positive charge, and they are called positive ions. Their chemical activity increases as the atomic number and the atomic size increase. Again, their chemical activity or their reactivity will increase from top to the bottom, together with the atomic number and the atomic size. They are named alkali because they react with water, forming alkaline solutions. Do you remember when we said that cesium is the most active metal? And I told you, be concerned with the corners of the periodic table. The cesium is in the lowest left bottom corner. This is the most active metal. Chemical properties of alkali metals. We will discuss now the reaction of alkali metals with water. If the sodium will react with water, it will form sodium hydroxide and hydrogen gas will evolve. Similarly, when the potassium will react with water, it will form potassium hydroxide and hydrogen gas will evolve. Both react with water. However, one of them is stronger than the other. If I will tell you that the potassium will react stronger with water than sodium, can you tell me why? If we will return back to the reactivity series, you will find that the potassium is more reactive and more active than sodium. That's why its reaction with water is stronger. Let's watch this video about sodium reaction with water.
We'll go down the column on the periodic table in group 1 and look at sodium. Like the lithium, the sodium is stored in a mineral oil to minimize reaction with the oxygen in the air. If we remove a piece of sodium metal, we notice that it's also coated over with an oxide coating. Group 1 metals become softer as you go down the column. The sodium is much easier to cut than the lithium. As we cut off the oxide layer, we can see the shiny metal underneath. It coats over very rapidly with a layer of oxide. The sodium is a metal and is an excellent conductor of electricity. If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense in water and floats. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt. The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by this single displacement reaction by trapping the gas and testing its flammability. We can test for the fact that we produce sodium hydroxide by adding phenolphthalein. The phenolphthalein turns a purple-red color due to the presence of the hydroxide ions, indicating the formation of the sodium hydroxide.
After you see the reaction of sodium with water, let's watch together the reaction of potassium with water.
If we continue down the column to potassium, we see that the potassium metal is also stored under mineral oil to minimize its reaction with the oxygen in the air. If we remove a piece of potassium metal, we can see that the potassium is coated over with a gray coating of the oxide. As we continue down the column, group 1 metals get softer and softer. The potassium cuts very easily. As we cut through the metal, we expose the shiny metal surface underneath. The potassium is extremely soft. We can easily flatten out the potassium metal. It has a consistency of cream cheese. The potassium is a metal and is an excellent conductor of electricity. If we add a piece of potassium metal to water, we see that it reacts much more rapidly with the water than the sodium. As you go down the column, the ionization energy decreases and the metal reactivity increases. The reaction is very exothermic and the hydrogen that's produced ignites. We can test for the formation of potassium hydroxide by adding phenolphthalein. The solution turns red-purple due to the formation of potassium hydroxide.
So now you believe that potassium reacts strongly with water than sodium. Now, can you think for 1 or 2 seconds why sodium fires cannot be put off with water? Yes, this is because sodium reacts with water. So, can you imagine that I put off sodium fire with water? Of course it will increase because sodium will react with water and hydrogen gas will evolve. Can you give me a reason why sodium and potassium are kept in kerosene? Did you notice from the previous videos that they keep the metals under the surface of kerosene to prevent them from reaction with oxygen in the air? They are so reactive metals. And why lithium is not kept in kerosene? Because lithium is less dense than kerosene. Therefore, it will float and burns because also it will react with oxygen. So that's why we keep it under paraffin oil. Can you take a second or two to fill in the blanks? Elements of group 1A are called alkali metals, and sodium is kept under the surface of, yes, kerosene, in order to prevent it from reacting with oxygen. Sodium floats on, of course, if we are talking about floating and sinking, we are talking about water. Alkali metals are what? Valent. I'm talking about electrons in the outermost shell. And its ions are, of course, they are monovalent. They have only one electron in the outermost shell, and its ions are positively charged. Correct? The underlined word. Oxygen gas evolves when sodium reacts with water. It's hydrogen, of course. Cesium is an alkali metal with least density. No, it's lithium, the first one in the group. Dear students, thank you for watching and see you later in other episodes.